business development with CG&A, and I want to say right off the bat here, thank you for being available this afternoon for our CG&A Web Institute training webinar. We've got really an outstanding presentation today, and we're very pleased at the number of people that have registered and are jumping on the line. So just a couple of quick things that I'd like to mention at the beginning, and then I'll introduce our presenter and we'll get going. To avoid background noise, many of you know this, if you've not been on one of our calls, we always mute all of the attendees. It just makes for a cleaner, less distracted presentation. So, however, Daniel's our presenter today, and he definitely welcomes questions, and we would encourage you, if you think of them during the presentation, don't wait, type them in, and he will address them as he's able to, either in the presentation or at the end. And then also there will be time at the end for questions. So just one other thing that I want to mention is this presentation today will be recorded. So if there's someone in your office, a CG&A member or customer that would like to have been here but couldn't for some reason, it's available for them to see. So anyway, that's a little bit of housekeeping. Let's get going here. I'd like to introduce, certainly ProLon is a long-time preferred vendor of CG&A, and I want to say they are and received an award from CG&A. In fact, our highest award. ProLon was the 2016 Preferred Vendor of the Year. So that award was presented in Memphis, Tennessee in April, and we are very pleased with how they have grown and really becoming a very important vendor to this group. So we're pleased to have them. I'd like to introduce Daniel Kerwin. He is the Business Development Manager, and he's going to be speaking today on the new ProLon FlexIO controller. So Daniel, welcome to the CG&A webinar. Thank you, and sir, it's all yours.
All right. Thank you very much, Jim. So my name is Daniel Kerwin, and I am the Business Development Manager for ProLon. So what we're going to do today is essentially look at one of our upcoming controllers. So as many of you know, with ProLon's set of existing controllers, they have mainly been application specific up until now. So when we talk about application specific, we're talking about controllers specifically designed for rooftop units, VAV dampers, heat pumps, boilers, and so on. However, over the years, there has been an increasing number of requests from all sides, whether it's from distributors or from contractors, to be able to develop some kind of I/O board which would be able to do or essentially achieve certain control sequences which we did not have in our existing product line. So here's kind of where the idea where we got to develop this newer controller. And so we decided to call it the FlexIO, as in flexible inputs and outputs. So without further ado, let's just take a look at this. So, and if you are already familiar with ProLon's controllers, you already know that for a wide-ranging range of applications, we usually have two different hardware models. There's the C1000 model and there's the M2000 model. And the main difference between these two controllers is the amount of inputs and outputs. So for the FlexIO controller, we continued down that same road. So we have developed this particular application, but in both hardware platforms. And so we have the C1000 FlexIO and the M2000 FlexIO. And as you can see here on the pictures, we can also see what the part numbers will be. So PL-C1000-FLX or PL-M2000-FLX. So obviously, like I mentioned before, between the M2000 and the C1000, we have a different number of inputs and outputs. So on the C1000 FlexIO, there's going to be 3 universal inputs, 1 binary input. On the output side, it's going to have 4 digital outputs and 1 analog output. And when we move over to the M2000 platform, well, this hardware platform has more inputs and more outputs. So it has 9 universal inputs, 5 digital outputs, and 3 analog outputs. So when we're looking at the input side, so what can we configure these inputs to be? So since it's a generally universal input, so we can configure it to be a temperature. It can be a pressure reading in inches of water. We have pressure measured in PSI. The input can be used simply as a contact. It can measure humidity levels. It can also measure gas levels as well. And so when we're looking at the actual nature of the input, like what is actually accepted in the input terminal itself, well, so it can be a thermistor, so any temperature sensor, which is a 10K type 3. It can accept a 0 to 5 volt DC signal. It can accept a 1 to 5 volts. It can also accept a 0.5 to 4.5 volts DC, because we know that there are a lot of pressure transducers out there in our industry which have this specific range. So we wanted to make sure to include that. The input can also accept a 4 to 20 milliamp signal. And well, obviously for the contact, so the input would simply be a dry contact. And as you'll see, beside the 4 to 20 milliamp, there's a little asterisk. We just want to point out that if we want to use the 4 to 20 milliamp signal on a C1000 platform, we will need a 250 ohm resistor to be able to convert the signal. Now, just keep in mind that if we're using the M2000 version, we do not need that resistor. So it is essentially native to the controller. All right. So for the outputs, so what can drive our outputs? So it can either be a local input, so essentially any of the inputs which you physically plug into the controller, well, that can be the source of the output. We can also control our outputs based on network variables as well. So some of these network variables can be occupancy, such as if we get it from our network controller. We can control our outputs based on our math functions. So our math functions is a feature in all our master controllers, like in the rooftop and in the heat pump controller, where essentially we can get essentially like a general zone demand from all our zones, just so we know if zones are calling for heat or calling for cooling. So we can use that to drive outputs. We can use the outside air temperature as the source for our output. We can also use the supply temperature. So if you have some kind of rooftop unit and we're monitoring what the supply temperature is, well, we can use that as our source as well, so we don't have to install an extra sensor. And we can also essentially drive an output based on the occupancy from the internal time clock on the controller. Now, just as a little reminder, this is applicable only for the M2000 because that one has an internal time clock embedded within it, whereas the C1000, it does not have that time clock feature. So, okay. All right. So what kind of logics can we put? Well, obviously, this being a flexible I/O controller, well, we can choose what we want our outputs to do. So what are the logics? Is it a heating logic or cooling logic, or direct acting, reverse acting? And what are some of the different kinds of actions it can do? Well, obviously it can be on-off. It can be a modulated signal, and we can also do pulse width modulation for the digital outputs as well. Now, we have added a few extra features on this, such as overrides on the outputs. So we can essentially, control an output any way we want, let's say whether it's based on pressure or on temperature, something like that. And then if we choose to, we can choose to override that output to a specific value based on either the outside temperature. So you could say if ever it gets hotter than this outside, then either turn it on or turn it off or whatever, as we will see on the software demo. And you can also override the outputs based on occupancy as well, because maybe you want the occupancy of a building to turn something on or off or something like that. We also have a output binding feature, in that essentially we can disable an output based on the action of another one. So we could say, let's say we have output 1 and 2. Well, we could say, well, I don't want my output 2 to turn on if my output 1 is on. So it's like a little condition like that. But we're going to get to see this on the software, so we will see this much more in depth. Okay, and just a little thing for the reprogramming of some of these controllers. So as many of you know, one of the features of ProLon's line of controllers is that you're able to reprogram a controller from one application to another. So if you have a rooftop controller with you and you really need it to be a heat pump application, well, you can reprogram it yourself just simply with a little button which will reprogram it. So so we stay true to that for the M2000. So essentially any M2000 controller can be reprogrammed into an M2000 FlexIO and vice versa. However, we cannot do that for the C1000 hardware platform. So it has a unique PCB board. So essentially, we cannot take an existing C1000 controller, which has another application, and convert it into the FlexIO. So unfortunately, we cannot do that with the C1000 FlexIO. All right, and let's see what's next. So next for the pricing, I believe. There we go. So as I mentioned in the email, the list price will only be mentioned here. So here we have the list prices for both of these platforms. And probably another one of the questions which we would receive a lot is, well, when is it coming out? When's it going to be released? All I can say is it is coming very, very soon. I would probably say late July, early August, roughly. So I can't give you a specific date, but I can give you an approximate timeline. So, all right. Well, that's it for the little PowerPoint. I just wanted to go over the basics of it, and now we'll get a little bit more interesting because I will actually configure one right now. So let me just close this. Okay. So here's my ProLon Focus software. So I just opened it up. And so I'm just going to go down to the new FlexIO icon. So obviously we have a new icon for that. So I'm just going to drag and drop it in. And it's going to ask for the address. I've already pre-addressed this one to number 10. Okay. So far so good. My FlexIO has showed up. So if I just double click on it, all right, there we go. So first of all, just taking a look at here. So obviously we have the date and times because this is an M2000 version. Here we have our local inputs. So the M2000 has 9 inputs on it, right here. If I scroll down a bit, we can, or I can actually just click here, and it'll minimize that little window. We can also view the network inputs. So we're monitoring outside temperature, supply temperature from some kind of master controller. We have our 5 math functions, and we also have separate 8 different occupancies as well. But I will get into that in just a moment. And here we have our outputs, but right now there is nothing listed here right now. So let's take a look at these things. So if I do config, let's say I want to go into inputs. Okay. So you can choose what you want your input to be. So I can just click on this drop down. So as you can see, it is very user-friendly, highly configurable. So it can be a temperature, it can be a contact, it can be a pressure in inches of water, pressure in PSI, gas levels, and humidity levels. So if I go here, temperature, and I could name this one, I don't know, let's say something that ProLon could not do up until now. Let's say I wanted to control say I wanted to turn on a chiller based on the cold water supply. That's it. So I will call this one cold water supply. Very good. And just for the purposes of this demo, I'm going to turn all of these off just so that it might make it a little bit easier to see. All right. And as usual, I will press on the apply button. Okay. So now analog input 1 is measuring the cold water supply. So there we go. So I can look at my inputs, and as you can see, it has automatically been renamed CWS for cold water supply. So let's say on top of this, so with this, I want to be able to turn on my chiller. So I just want to do it with a simple digital output. So I'll do config digital output. I'll go on my DO1. So it's going to say source. So essentially what is driving my output? I'm going to choose a local input here. And here we would have a list of all our inputs, but right now I only have my cold water supply. I could call this chiller start stop. And you can choose, is it a heating or cooling logic? So I'll probably want it on a cooling logic. And I can choose what my set point is. So let's say for the purposes of this demo, I want the set point to be 40 degrees, let's say. And you can choose what is the differential band. So if I change this, say I put this to 5, just to keep it nice and round. Oh, it's okay. All right. So, and here, as usual, if ever I just hover over it, there's going to be a little yellow pop-up, which is going to let me know. So I take half my differential band on each side, and so I'll know I'll turn on my chiller once it reaches 42.5, and I'll turn it off once it reaches 37.5. So there we go. And if I just go back to the home, and I just call this, so here I can see I have my chiller start stop. So it'll either be 100% or 0%. All right. What else? So I can also, like I said, we have these override conditions as well. So I could say, well, if my outside temperature gets below I don't know, let's say if ever it goes below 25 degrees outside, you can choose, oh, that's okay. So you can choose what is the output going to do. So do we want to keep it on, keep it off? So I could say, well, if it ever gets colder than 25 degrees outside, I want to make sure that my chiller stays off because I probably don't need it anyways. So there we go. We could also add on based on occupancy. So I could also turn it off. I could force my chiller to off, or essentially disable it, if ever the schedule becomes unoccupied. And we also have a little or and right here as well. Very good. Okay. Okay. Let's say another application that people I've seen do is for like exhaust fans. Sometimes they'll have multiple exhaust fans, and they just need a simple exhaust fan with a proof of exhaust. So I could essentially go onto my DO2. Essentially, we could choose his like what's going to turn it on and turn it off is essentially going to be a occupancy. So it's going to go strictly based on occupancy, and I could call this one exhaust fan 1, and I could say output is on when it is occupied. So press on apply. So there we go. So I've got fan 1, and let's say that I have another one. So I'll call this one exhaust fan 2, and it'll turn on when it's occupied as well. So now I know when the fans turn on, and now I just want to make sure that I have the proof of fan. So in this case, I'm going to go into the inputs, and this one is simply going to be a dry contact. So I could say the proof exhaust fan 1, and so when contact is closed, so we can choose what is displayed when the contact is closed. Is it like a yes? Is it a no? Is it on? Is it off? So I could say, so since it's called proof, well, I would want to say yes. So do we have proof? Yes or no? And I could go, this one would be proof EF2, and I'd also do yes right here. There we go. All right. And then when I go back home, so I can see that essentially I have both fans are on right now, but I have no proof. That's normal because I don't have anything plugged into the actual controller right now. So, all right. Well, what else do we got? Let's say, so if I just kind of go down here, so let's say I want to use input 4, which is still relatively free. So let's say I want pressure in inches of water. Well, maybe I want to control building pressure. So maybe there's a supply fan which is in the system, which is maintaining a constant static pressure. But maybe there's like some kind of relief fan or some kind of return fan, which that one is going to modulate to maintain the building pressure. So in this case, I will call it, let's say, fan VFD. So what I'm going to do is, so here we can choose, is it a 0 to 5 volt, 1 to 5, 4 to 20, or 0.5 to 4.5. So it all depends on the pressure transducer, and you can put what is the range right here. So is it 0 to 1 inches, 0 to 2 inches, 0 to half an inch? You guys choose. So whichever transducer you have, we have the input, and the user can set up what the range is. So here I could actually I would call this let's say building pressure. Okay, something like that. Oh, so I'll call it. We can only do 16 characters. Building pressure. Okay. All right. So here I've got my building pressure, which here is what I'd be measuring. And then, so if I go to my output, I'd have a analog output this time because I have a some kind of VFD. So my local input would be my building pressure right here. And maybe I'll call this the, let's say, fan VFD. It's maybe a relief fan, or let's call it return fan VFD. So, and here we can essentially put what is our set point here. So I put this to, let's say, 0.1 or something like that, and my differential would probably be something like that right here. And we would want to make sure that it's reverse acting. And here we want to make sure that it is not differential, it's not on-off, but we actually have a proportional integral right here. So because it is a modulating signal right here. And so supply, and there we go. That's all we need. And here you can choose, obviously, what is the range here for our voltage range for the VFD. Very good. And at the same time, I could say, well, if ever my building becomes unoccupied, well, at that point, I could simply just disable that fan because maybe we don't need to worry about building pressure when it's unoccupied. So just to give you an idea of different things that we can do here. All right, and there we go. So here we're looking at our building pressure with the return fan VFD. All right. Continuing here, we can also do pressure, but in PSI. So maybe something that ProLon has been able to do with certain of its controllers is to enable and disable pumps. So we have pump control. However, something that we were lacking was the pump modulation. So we didn't have any analog outputs for that. Our controller's not designed for that. Well, with this, we will be able to do that now. So I could call this maybe a P1 pressure. And so I could look at this. Essentially, what do we have here? What is our range? So I don't know. Maybe we have like a 100, like a 0 to 100 PSI range. And so obviously, I want to control some kind of pump VFD. So I can just go on the analog output, go on analog output 2. Local input will be my pump 1 pressure. So this one will be P1 VFD. So once again, here I don't know, maybe I have a 50 PSI set point, and I'll have a little PI loop going on here. So maybe I'll put this maybe to 10 PSI or something like that. And there we go. There we go. So now I have my where is it? So I have my pump 1 pressure and my pump 1 VFD. And in case you guys had not noticed yet, when you go into your actual menu, well, we still see all our digital outputs, but it has also been renamed based on what you chose to name it as well. So you're not always searching what did you put on digital output 2 or 3, or you don't remember. So we made sure we wanted to keep it as user-friendly as possible. So once again, just so that people can do their configuration very quick and very efficiently. Continuing down here, I could say, okay, I also want to measure gas levels. So maybe we have some kind of carbon monoxide. So I could do CO levels, so carbon monoxide. And here, I'm pretty sure this would be a lot smaller. So let's say it's 0 to 50 ppm. I am not quite sure what the usual range is on this, so you'll forgive me if ever my range is a little bit off, but just to give you an example. And here, well, we might have an actual 4 to 20 milliamp signal going in. So there we go. So here I've got my CO levels right here. And if I go to my, so let's say, I don't know, I just want to enable a contact, which is going to start a fan, open up a damper, and so on and so forth. So I could go into my DO4. My local input will be the CO levels, and also I'll call this maybe CO, I don't know, I'll call it evac for evacuation. So obviously, we would want it to be direct acting. So as the levels go up, we want to initiate it. So maybe so 0 to 5. So maybe I'll put 20 ppm with a differential of, let's say, 4 or something like that. So once I kind of go here, so I'll know that my carbon monoxide evacuation sequence will start at 22 ppm, and we will deactivate it once it goes down to 18 ppm. So there we go. Okie doke. And obviously we can see all of that here, right there. I think we just have one left. If I go into the inputs here, so it can be humidity levels. So once again, I don't know, I could call this pool humidity. Here we go. So we can choose what is the signal. So I'll just leave it like this for now. So here I can measure what the pool humidity is right here. And if I go on to analog output, I don't know, maybe I just want to be able to turn something on, which will essentially dehumidify. I will go into DO5, local input. I'll look at the pool humidity levels, and I'll just put a dehumidify. There we go. And I will put this basically as it goes up, so it'll be direct. I don't know, maybe my set point is 60, so I don't want it to go much above 60, although it is a pool room. So and then I put this maybe at, I don't know, something like 10. And there we go. So now I've essentially set up this particular controller, as you can see, to do a wide variety of different applications. So there we go. Now, you will notice that on this icon right here, that all we see is this green icon, but usually we have different lines which would be written depending on the controller. So you can see either zone temperature or supply temperature or humidity levels, math functions, you name it. Well, since we didn't know exactly what people would want to see, we said, well, why don't we let the people choose what they want to see on that little icon. So if we just go on config, icon setup, so we have 3 lines. So you can essentially choose any of the inputs and outputs which have been configured, and we can have it show up. So let's say I want to look at the CO levels. I want to look at the I don't know, let's say I want to look at the chiller start stop, as well as the cold water supply. So if I press on apply here, I will see my 3 lines pop up. And there we go. And as you know, our icons are usually typically it can be one of 3 different colors. It can be green, it can be blue, or it can be red. So in this case, we can choose what color goes with what. So I could say make icon red if ever, if ever my evacuation sequence for the carbon monoxide is on, and I could make it blue essentially when my chiller is on as well. So And we could just leave it like that. But once again, you guys can choose. And here we have a little note here in case the icon wants to be red and blue at the same time. Well, the red color will take priority over the blue color. All right. If I go back to this, I think this is the last available output that I had. So so far, I've been basically making it go off of the local input every time. I can also choose a network variable. So once again, here we have all the network variables. So outside temperature, supply temperature, our 5 math functions, and here we've got our 8 occupancy slots, which I will get into in just a moment here. So I could say, I could drive something simply based on outside air temperature, or I could drive it simply based on occupancy. Whatever you want, we can do that. So I'll just talk about occupancy and so on. It kind of brings me to the network controller. So what I'm going to do, so how is this FlexIO receiving different occupancies? So I can go, so I'm just going to jump up a level here, and I'm going to bring in my network controller. There we go. It's going to turn green. Okay. So here we go. I'm just going to open it here. All right. So here we have our different schedules, which I already had. So what I can do, as you know, we can make different kinds of schedules. We can handle up to 16 schedules here. And so what I can do is in config distribution, so I want to distribute a schedule. So now it's essentially, so here, when you add a controller, well, it also includes the FlexIO slots as well for occupancy. So if I say slot number 4, well, he's going to follow schedule number 2. And so when I do that, and then I go back onto my FlexIO controller, I can go into any given output. So let's say I go onto this output, and I'll just change this one. There we go. So I can make this one go based on slot number 4. So now my output, so this specific exhaust fan is going to be controlled from the schedule coming from the network controller. So that means that we could technically have 8 different schedules controlling 8 different outputs. So you could, I mean, there's nothing stopping us from controlling 8 different exhaust fans or lighting controls as well. And plus, when you add that on with the contact inputs, it means that we can find out are things on or off and so on. So as you can see, we have a lot of different capabilities now, which is a little bit beyond what we were able to offer with our current product line. And once again, since this is a M2000 controller, well, it can have its own internal schedule as well. So here's where we would play with its own internal schedule here. And I think maybe just the last thing, which I did not get into too much, was, let's say I've got my 2 exhaust fans, and I want to go into the output of exhaust fan number 2. Well, I could say I want my exhaust fan number 2. I want to activate it or deactivate it, whatever we want. I could say I want to deactivate it if ever my exhaust fan number 1 is on. Because maybe in that specific application, it's I want them both there, but if one's working, I do not want the other one to turn on. So that's a little example for that. So that basically resumes what I wanted to show you guys today. Now, it's not, it wasn't intended to be a full training, but just a simple sneak peek at what is coming up. So like I say, it's gonna be late July, early August, and we're going to send out an email to everybody to let them know. In case you are not on our email list, just make sure to keep in contact with your local CGNA distributor, as they should have all of this information as well. So that basically concludes my presentation. I don't know if there's anybody who would have any kinds of questions or something like that.
All right, good. Daniel, very good. This is Jim. I just jump in here and mention to everyone on the webinar, this is your opportunity to type in a question. And in just a moment, I'll ask Peter if he's got any that have come on his screen. I have one, Daniel. You said late July, early August. You're not talking about next year. You're talking like in the next 2 to 3 weeks was your guesstimate?
Yep. Okay. Exactly.
Okay. So real soon. So you say you expect it to. Okay. Good.
Right.
Do you see any on your screen there, Daniel, or Peter? Do you have any questions that have come in?
Yeah, there's a couple of questions, Daniel. Can you open your questions tab?
Okay. Okay. Yeah, I see. Yeah. So what yep. Alarm options are possible? That is a very good question. So so I'm guessing we're probably talking about possibly the email alerts, like email alarms. So what I could do is if I go back onto this network controller right here, just wait for it to open. Okay, so what I'm going to do, I could go into alerts. Oh, I'm going to take all these off. I don't want to show the end result before I show it to you guys. All right, so what I can do is I can add on, let's say I want to add on, so what device do I want to monitor? So I could look at the FlexIO controller, and then in the source, well look, we made sure that everything that you rename, every single input, every single output will show up in the network controller as is. So you're not going to be looking at DO1, DO2, and so on. Everything is renamed. So I could say if ever my CO levels goes above 25 ppm for a certain amount of time, send me an email. We can also bind some of these things together. So let's say I'm looking at the FlexIO as well, and I want to look at the, no, not the CO levels, but the evacuation. So essentially, so in this case, it would probably be over, so basically anything over 0%, which would mean yes, because it's a digital output. It's either on or off. So if I put these in the same group together, so it means if my CO levels are above 25 ppm and my evacuation hasn't turned on yet, well then, you know, I might have an issue. Or I might have some kind of proof, like some kind of damper proof or some kind of exhaust fan proof. And so I would just kind of tie all of those together. Let's say if I just look at another one. So once again, I could look at, let's say, my chiller with the cold water supply. So if ever my chiller is essentially off, no, sorry, if it's on, and my cold water supply continues to be above 50 degrees, which is not what I want because my set point is 40, and maybe this has been true for maybe maybe we'll put a bit more time here. So in this instance, if my chiller's been on for 6 minutes and my cold water supply is still above 50 degrees, now I want an email, and we can send it to different up to 3 different email addresses as well. So once again, you choose. Any other questions?
Okay. Are those the ones that you have? You answered them all.
Oh wait. I'm actually just scrolling up here. Okay, here we go. Let's see. Okay, so what communication protocols are available in the boiler controller? Well, as the rest of our product line, it is a Modbus only communication protocol, with the exception of our VAV controllers. So the VC2000 VAV controller, that one can communicate Modbus and it can communicate BACnet as well. If I just scroll down here, okay, is heating and cooling logic the only options on digital outputs? So it's heating, cooling, or can be direct acting, reverse acting. So it's essentially the same action. It's just renamed in a different manner. And I'd say that the important part, if one way of saying it is not clear enough, you can always just refer back to the little pop-up. So if I go on to, let's say here, well, just hover over the word differential, and you'll see when does it turn on. Is it direct acting or reverse acting? And if I were to change this to heating mode, well, in this case, it would be, we will see that the little pop-up graphic has essentially inverted itself to show a reverse acting logic here. So there we go. All right. Okay. That's. Oh wait. So we have a question about how to do point-to-point drawings on FlexIO. I'm not quite sure exactly what the person means with that. So unfortunately, I cannot answer at the moment, but I know who asked the question, so I will give them a call after this presentation to know exactly what he meant with that. So.
Okay, good.
All right. And that is all I have.
Okay. Peter, do you have any other questions that have showed up on your screen?
No, that's it, Jim.
Okay, okay. Well,
very good.
We'll just give another moment, but otherwise, Daniel, great presentation. Thank you. Thank you for all the information here. Looks like a very cool product.
Very good.
Daniel, you know what? You might do one last thing. Daniel, can you shoot your contact information up on the screen if anybody would like to grab that before you go?
Yes. I'm just going to open up a little Word document here. So, so here is my email, proloncontrols.com. So Daniel.Kerwin. So we have the autocorrect. If ever you need to reach us at the office, our number is 450-973-5100, and my extension is 807. And if not, you can also always reach me on my cell phone as well. It is 514-717-6494. So in case I am out on the road, you can always leave me simply a voicemail on my cell phone, and I will get back to you as soon as I can.
Okay. Daniel, I have another question. This is Jim. One of the things that you mentioned is that this was more of an overview and not a full training. What are your plans in light of training for this product? You're going to do webinars, you're going to lunch and learns, or what do you foresee there? Have you guys mapped that out?
I'd say it is still being planned out at the moment. As you know, Angie and I, we usually have our, we usually travel a lot in the spring and in the fall, because that's usually when people are ready to see us, because the summer months, things are a bit too hectic with contractors and so on. So we're going to be doing another batch of visits this fall. So that will be a great opportunity for some one-on-one presentations. However, we will likely be sending out kind of general requests or inquiries if people would like a webinar, and we'll be contacting each distributor individually so that whether they prefer to do it in person or would they like to do it in a webinar.
Okay. All right. Very good. Well, if there's no other questions, I think, well, let's, Daniel, feel like we're at a good stopping place?
Yep. It's fine for me.
Good. Well, listen, I want to say thank you especially to all the CJA members and customers that have been on the call. Thank you for taking time out of your afternoon to be on the webinar. We appreciate you being a part of this. Daniel, I want to say thank you for a great presentation, and let's get this product out there. It sounds very good. So, Peter, Fan, thank you for handling the IT out of California, our office out there. Appreciate this. So, everybody, have a great afternoon. Thanks again, Daniel.
All right. Thank you very much, everybody.
Bye-bye.
All right. Bye.